Tech Revision with Mrs. Swanee Pooh. Hi Year 11, this is the first of many revision videos for your mock exam. So I'm hoping to cover a few things that we didn't quite manage to get through in lessons. And the first one we're going to talk about today is forces and how these act upon products. So you can see I'm in my house here. So it's currently 20 to 10 at night, so apologies if some of this sounds a little bit unrehearsed, but I obviously want to make sure that you've got all of this information in plenty of time to do some revision. So hopefully you can see the screen in front of you. I am aware that maybe my picture is obscuring a little bit of it, but I'll attach the PowerPoint as well separately so you can have a look at that as well. So the first thing I want to talk you through are all the different forces that you need to have an awareness of. First thing is, we always say quite a lot about how materials are strong, but what you need to know is that if a material is strong, it means it can withstand a lot of force without bending or changing shape or breaking. So for example, my PlayStation controller here, if I was to try and twist this or bend it, I'm not obviously going to do it very hard because it's about 50 quid's worth, but if the material can hold its shape without breaking or bending, you would say that the material is strong. Okay, so certain products like a bridge material that a bridge is made from, you don't want that to be bending, you want it to be maintaining its shape. Okay, so we're going to talk through these forces one by one. I'm going to give you some examples and talk really quickly about them. So the first force that you need to know is tension. And any of you that have watched Squid Game lately will know the tug of war game is a really good example of tensile forces or tension because it's a pulling force. So this can quite often act on something like a rope or a cable or a chain being pulled, sometimes in opposite directions, boop, or sometimes just from a fixed point. So it could be, for example, a seat belt as it's pulled across you, or if you're in an accident, the force acting upon it would be a tensile force. It could be a child swing, so the chain would be under tension. So tension is all about a pulling force. Okay. The next one we're going to talk about is compression. So that's when something is squashed. So for example, my pillow here, if I was to squash it, that is compression. Okay, so an example of this is a bridge when it's being pushed down with the force, a tennis ball when it's hit by a tennis racket or a golf club hitting a golf ball. You'll see in a slow motion the ball actually compresses before it, that's why it goes off at such a speed. And also we've all played with plasticine, so when you squash plasticine, that is compression. Okay, so I think those first two are quite easy to understand. They're kind of opposite forces. So tension, pulling, compression, pushing together or pushing down on something. Shear is a little bit more confusing. You can see on the little diagram there that it's when things go in opposite directions. So it's when one part of a surface goes in one direction and the other one goes in the other. Okay, and it's kind of like parallel to each other. So some examples of that are some scissors. Yes, these are scissors. When you've got the two blades of the scissors going in different directions, but along the same angle, if you see what I mean. Slicing bread, tearing paper, those are all really good examples of a shear force. So yeah, that is when a force acts kind of like across each other. Okay, so it's not like this way or anything like that, it's kind of across. The next one is a bending force. This is very simple. It's normally applied to like a thin length of material. I'm looking around my house to try and find something. Can't find anything decent, but basically some good examples of that are things like tent poles. If any of you have put tents up before that have got these like plastic tent poles, they have to bend to go inside the tent fabric. It could be bridge beams, as they've got pressure on them, compression on them, they will bend at a certain point. A diving board which is fixed at one end, when the pressure is on this side it will bend. And if any of you are fishing, I should play charades. I'm just acting all of these out perfectly. A fishing rod, when you actually go to cast, the fishing rod will slightly bend, and if you catch a fish, the weight on the end will cause the fishing rod to bend. Okay, so it's when a force is applied at a certain point, normally away from where it's fixed. So for example, my elbow here, if I was to push on my arm, it's obviously not quite right, but it's kind of like it's got like a bending force on it. And the last one is called torsion. Now, when I was a kid, there was a very probably un-PC game now, which was where you'd grab someone's wrist and you'd twist it like this. I don't know if anyone does that still. It's not very nice. It hurts. It burns in a way. But that's called a torsion. Okay, so when you twist, that force is called torsion. And some examples of that are things like screwdrivers. When you're screwing in a screw with a screwdriver, there is a torsion force on the screw as well as the actual screwdriver. So you need to make sure that they're not going to fracture in that force. Other really good examples, this force can also be called torque. So any of you petrol heads out there will know that a lot of torque goes on something called the drive shaft in a car, which spins quite quickly, and that has a lot of twisting and a lot of torque on it. So that's the force that it needs to withstand. Okay, so torsion, Rubik's Cube has torsion, so it's twisting. So that is a really, really quick overview of all the different forces that you need to be aware of. And now what I'm going to do is I'm going to show you some examples of some questions. Okay, so in the exam, you could have a picture of a product in front of you. So here's a bridge, and it could ask you what forces are acting on the product. So have a think to yourself at the moment, which of these types of forces have we just kind of spoken through? So if we go back to the previous, I can't go back to the previous slide, but never mind. Basically, you've got two different forces, or potentially three different forces acting on this bridge. Think to yourself which ones they are. Pause it here and have a think, write it down. Hopefully you've now unpaused, and here is what you should have written down. So you've got tension, so a pulling force on the cables of the bridge. You've got compression in the middle, where the weight of the bridge is pushing down, and whatever goes over the bridge is going to be going to have a compression force going down. But bending is also acceptable because potentially, not likely, but potentially there could be ever so slight bending or flexing of the bridge. Don't really want that, but those are some of the forces that would act on a bridge. Okay, I'm going to show you another one now. This one, I don't know if anyone had this toy. I remember I drove my parents crazy with it one Christmas. So this is called Bop It, and there are three forces acting on this toy. So pause here and try and write down the three forces. Right, hopefully you unpaused, and these are the three forces that you should have had. So on the one side, we've got torsion, where it asks you to twist it. The bop it in the middle is a compression, because you're pushing the button in. And the end where it says to pull is a tension force, because you're pulling that out. Right, last one is this one, which is a car seat, children's car seat. And there is a force acting on the straps of the seat, so the actual straps that go around the child, and also a force acting on the seat area. So pause, have a quick go. Back. These are the answers that you should have had. So you can see you've got tension, excuse me, acting on the straps of the chair, and you've got compression from the weight of the child pushing down on the seat. So those are three really quick examples of the kind of thing that you could face in your mock exam. What you need to make sure is that you use the correct names for the forces. So make sure you're really clear on what those are, and you don't make the mistake of writing something completely random. Like, for example, I quite often have answers like, oh, gravity is acting upon the product. Well, yeah, it is, but that's true of everything. And you need to think about how the product is used and how the forces are going to impact that product. Okay, I hope that was useful. there's going to be more of these videos, so keep your eyes peeled and make sure that you watch them maybe a couple of times just to get the main sort of points down. I'll see you guys soon. Let me know if this is helpful, and if you've got any questions or anything, you know you can always email me. I will try my best to respond even over half term. Bye everyone.